Okay, so hello and welcome back. So now let's go through example number 12 and 13, and these are the last examples in this chapter, and then we will talk about the exercises. So example number 12. Example number 12, we want to simplify tan inverse of a cos x, a times cos x minus b times sin x over b times cos x plus a times sin x if a divided by b tan of x is greater than -1. So if that's the case, we want to simplify this and greater than -1. Okay, so now in order to simplify this, what you can do is that if I divide the numerator and denominator by b times cos x, I can write basically the tan inverse of a times cos x minus b times sin x, b times cos x plus a times sin x. Right, I can do that, and of course taking this into consideration that basically a by b times tan x is greater than -1, I can write it as the tan inverse of, divide both numerator and denominator by b times cos x. So I can write a cos x minus b sin x over b times cos x. Now b times cos x plus a times sin x over b times cos x over b times cos x, and basically then you want to take the tan inverse of that. Now cos x and cos x will cancel out here, so you have a by b. Actually, I have to write it in a different way, meaning that I can write this as now as the tan inverse of a cos x by b cos x minus basically b sin x by b cos x, and then I have b cos x over b cos x plus a sin x over b cos x, and then cos x and cos x cancel out, b and b cancel out, cos x and cos x and b cancel out, and so you have basically a by b minus tan x. So you have the tan inverse of a by b minus tan x, and over here you have 1 plus a by b tan x, a divided by b times tan x, and so a by b minus tan x 1 plus a by b tan x. Okay, so so basically now what you need to do is that since you have the tan inverse of a by b minus tan of x over 1 plus ab times tan x, basically in the formulas that we had before, we said that basically the tan inverse of x minus the tan inverse of y is equal to tan inverse of x minus y over 1 plus x times y, right? So based on this formula, we said that the tan inverse of x minus the tan inverse of y is equal to the tan inverse of x minus y over 1 plus x times y for all x times y greater than 1. Now you can compare this side of this equation to this expression, and therefore you can write it as the tan inverse of basically a by b minus the tan inverse of tan of x, which is equal to the tan inverse of a by b minus x. And that is the simplified version of that expression. That was question number 12, or example number 12. Now example number 13 is you want to solve the tan inverse of 2x plus the tan inverse of 3x is equal to pi by 4. Now the solution is, so you have the tan inverse of 2x plus the tan inverse of 3x is equal to pi by 4. So we know that basically the tan inverse of x plus the tan inverse of y is equal to the tan inverse of x plus y over 1 minus x times y. And so if I write this side of this equation as basically the LHS as the tan inverse of basically 2x plus 3x 2x plus 3x minus 2x times 3x, I will have the tan inverse of basically 5x 1 minus basically 6x squared. So now if I call this 1, therefore 1 becomes the tan inverse of 5x over 1 minus 6x squared is equal to basically pi by 4, which is equal to the tan inverse of 1. Of course, 1 has to be in the domain of the tan function, which you have to check. So let me see. Okay, so basically in the so over here we said that the tan inverse function, for the tan inverse function, the domain is basically all the real numbers, and the range is negative pi by 2 to pi by 2. So pi by 4, of course, is in the range of the tan inverse function, and the input is all the real numbers, which means that just a little bit back. Okay, so now I know that the tan inverse of 5x over 1 minus 6 times x squared is equal to the tan inverse of 1. Now what that means is that this is the tan inverse of some ratio. This is the tan inverse of some ratio, and again this is the tan inverse of some ratio. And I think the only conclusion that I can make here is that 5x over 1 minus 6 times x squared is equal to 1. Now I have to look at the solution here because I'm not really sure about that. It seems that it's right, meaning that from this I can conclude that 5x is equal to 1 minus 6 times x squared, which means that negative 6 times x squared minus 5x plus 1 is equal to 0. Or I can say that 6 times x squared minus 5x plus 5x minus 1 is equal to 0. And then I can solve this equation. Now in order to solve this equation you have to factorize it. In order to factorize this, what you need to do is that you have basically, if you multiply this negative 1 by 6, negative 1 times 6 is equal to negative 6, and then you have basically a 5 over here. Now you need to be looking for two numbers such that the two numbers a and b, such that basically the product of those two numbers ab is equal to negative 6, and a plus b is equal to 5. And a plus b is equal to 5. So that means that basically 2 and 3 and if I go for 1 and 6, for example, negative 1 and negative 6, no, I'm sorry, not negative 1 and negative 6, negative 1 and 6. The product of them would be negative 6, and 6 minus 1 is equal to 5, right? So the numbers are negative 1 and 6. Now I need to use these two numbers in order to rewrite this expression, rewrite the middle term of this expression, this equation, meaning that I need to write 6x squared minus x plus 6x, which is the same thing as 5x, minus 1 is equal to 0. and then take these two together and take these two together and factorize. Basically take 6x out, 6x times x plus 1 minus x plus 1 minus x plus 1 is equal to 0, which means that basically x plus 1 times 6x minus 1 is equal to 0. And that means that basically either x plus 1 is equal to 0 or 6x minus 1 is equal to 0, which means that x is equal to negative 1 or 6x minus 1, or basically or 6x is equal to 1, which means that x is equal to 1/6. So either x is equal to negative 1 or x is equal to 1/6. Now, of course, you need to go back to the equation that you had and test these numbers, meaning that the equation that we had was basically the tan inverse of 2x plus the tan inverse of 3x is equal to pi by 4. Now if I write if x is equal to negative 1, then we have tan inverse of negative 2, tan inverse of negative 2 plus the tan inverse of negative 3 is equal to pi by 4. And this I can write as the tan inverse of basically negative 2 plus negative 3 over basically 1 minus negative 2 times negative 3, and that is equal to pi by 4. And that means that this is the tan inverse of negative 5 over, this is positive 6. 1 minus 6 is equal to negative 5. Seems that it actually works. If x is equal to negative 1, tan inverse of negative 2 plus tan inverse of negative 3, that is equal to the tan inverse of negative 2 plus negative 3 over 1 minus negative 2 times negative 3, that's negative 5, and over here you have basically negative positive 6, 1 minus 6 is equal to negative 5, and then you have the tan inverse of 1 is equal to pi by 4. It seems that it works. I don't know, in the solution they have not accepted this one, but as far as I can see, the tan inverse of negative 5 by negative 5 is equal to pi by 4, which means that the tan inverse of 1 is equal to pi by 4, and that is true. Well, I don't really know how what they meant by this, but at the end of the day, if I try basically the tan inverse of, if I try x is equal to 1/6 as we found here, then this becomes the tan inverse of 2 times 1/6 is equal to 1/3 plus the tan inverse of 3 times 1/6, 3 times 1/6, which is equal to 1/2, is equal to is equal to pi by 4, and that is equal to the tan inverse of 1/3 plus 1/2, 1 minus 1/3 times 1/2 is equal to pi by 4, and that means that basically the tan inverse of 1/3 plus 1/2 is equal to 1/3 plus 1/2 is equal to 6. 6 divided by 3 is equal to 2 plus 3 is equal to 5/6. 5/6. And over here you have 1 minus 1/6, which is equal to 6/6 over 6/6 minus 1/6, which is equal to 5/6. And that is equal to pi by 4. And then tan inverse of basically 1 is equal to pi by 4, which is true. So that's basically the solution here. Now I don't really know, in the solution I must say that they have basically they have not accepted this solution. Now that's up to you to decide what you want to do with this. Anyway, the miscellaneous examples here are done. We have a couple of miscellaneous exercises on chapter 2. We will go through them in the next video. I'll see you in the next video. Thank you.